Hello, I'm Seema and welcome to part 13 of the chapter Periodic Classification of Elements. In this video, I'm going to tell you how the periodic table is divided into metals, nonmetals and metalloids. Do you know, out of the 118 elements in the periodic table, 78% of these are metals. And it's only 22% that are nonmetals and metalloids. What are these metals like? Metals, they are usually solids. An exception to this is mercury. Mercury is a metal that's a liquid on Earth. And it's the only metal that's a liquid. Gallium and cesium, they have very low melting points, so sometimes under certain conditions they may appear as liquids, but actually usually they are solids. All other metals, they are solids. Let us just see, where do we find these metals in the periodic table? The alkali and the alkaline earth metals, that is the S block, are all metals. The D block are also all metals, that is why they are called transition metals. The inner transition metals, the lanthanide and the actinoid series, are also metals. And if you see the P block, do you see the red shaded area that I've made? These are metalloids, and the ones to the left of it, they are metals, and the ones to the right of it, including boron, which is a nonmetal, are nonmetals. So we have metals all over from here to the red portion and the lanthanide and the actinoid series, which form about 78% of the periodic table. And it's really interesting, that all the variety in elements that you see, most of that variety, or rather 78% of that variety are metals. But what we see around us, like the earth is predominantly made up of silicon dioxide, and both silicon and oxygen, they are here, they're not metals. And the human body is mainly made up of carbon, hydrogen, oxygen. Most of the non-metals with just traces of metals are there in the human body. It's the same with all plant and animal life. So, although 78% of the periodic table is made up of metals, what we see around us on the crust of the earth, whether in the living or the non-living crust of the earth, we predominantly see non-metals. That's interesting, isn't it? But it is metals that form the widest variety of elements. Now, what are the properties of these metals? Metals are malleable. The property malleability means that if you take a piece of metal and you start hammering it, what will happen? The metal, when you hammer it, instead of breaking down, we find that it starts flattening. It flattens, and if you continue to hammer a piece of a metal, you find it forms a sheet, it forms a foil. You use the aluminum foil, it's very commonly used. We have gold foils, silver foils. So these foils are made because if you just keep on hammering a metal, it'll turn into a sheet. And this property is known as malleability. That they do not break when you hit them, when you hammer them. Rather, they flatten and form sheets. Ductility. We say metals are ductile. If you warm up a metal and when it becomes a little hot and it starts melting, and you just pluck a portion of it and you start pulling it, we find that instead of that part breaking and coming into the tongs that you're holding it with, it starts pulling and making a wire. So when you pull at a metal, instead of breaking, it turns into a wire. It continues to form a wire, and this property is known as ductility. So ductility is the property by virtue of which you can pull metals to form wires. Metals are usually good conductors of electricity. The reason for that is the electrons that they have and the ease with which they can lose those electrons, they make them very good conductors of electricity. And now the non-metals, which fall to the right and the top of the periodic table. If you see, this side are the non-metals, and this side all are the metals. The strong non-metals would be on top here. Forget the noble gases, because the noble gases do not react. the non-metallic part, they are non-metals, but they do not react. So the top of the periodic table here, this consists, as you go from the right top, would form the strongest non-metal. Therefore, the opposite of a non-metal is a metal. Therefore, the bottom left would form the strongest metal. Anyway, that's just for information. Non-metals are usually found on the top right of the periodic table. These are solids or gases. We notice that both in metals and non-metals, there's only one metal that's a liquid, and that is mercury. And in the non-metals, there's only one non-metal that's a liquid, and that's bromine. All others are either solids or they are gases. They have low melting and boiling points. They usually do not melt and boil at very high temperatures. But remember, there are always exceptions. The melting and boiling points of boron and carbon are exceptionally high, and there are reasons for that we'll study later. They are poor conductors of electricity. They do not conduct electricity because they do not have those free electrons. And again, there's a beautiful exception to this. Graphite, that is carbon, in one of its allotropic forms, is a very good conductor of electricity. So there are no, real demarcations or lines for the properties, and there always are stark exceptions, but then these are the general properties that we see in these categories. They are poor conductors of electricity, and they are brittle, and that means they are not malleable or ductile. If you take a piece of a diamond and you hammer it, guess what will happen? It's not going to flatten and make a beautiful diamond foil. It'll just fracture. It's simply fracture and the diamond will be destroyed. So don't ever try it. Don't try to check the physical properties of diamonds. So they are brittle, they are not malleable, they are not ductile. You can't draw them into wires, you can't beat them into sheets. If you try to beat them or damage them, they only get fractured and damaged forever. So these were metals and non-metals. Between the metals and non-metals, you can imagine, when God made the elements, he said, okay, you're going to run over that line. Now that's the finish line. And all those who run beyond the finish line, it's a race. All those that can run beyond it would be non-metals, and the ones who stay behind would be metals. So these metals were heavy and they were trying to run, but they could not reach the finish line. So they stayed in the core of the earth. They formed the heavy metals. They are inside the core of the earth, and they couldn't really reach the finish line, which was almost near the crust of the earth. But non-metals, they were lighter, they could run, and they just crossed over that finish line and they formed the non-metals. And these, the ones in between, were the poor guys who, while they were running and when the race stopped, they had 1 foot into the metals and 1 foot into the non-metals. They neither had all the properties of metals, nor could they acquire the properties of non-metals. They were somewhere in between. So these guys could not decide where they were, and they formed the metalloids. In the periodic table, we find the metalloids to form a zigzag staircase-like structure, and that is where they are present, very few in number, but they are the guys who could neither be on the non-metallic side nor on the metallic side, and therefore show the properties of both few metals and few properties of non-metals. So this was the classification of the entire periodic table into metals, non-metals, and metalloids. And after this, in the next video, we are going to start doing the periodic trends, and that would be where all our study has led to know the trends that physical and chemical properties show in the periodic table. Thank you for watching. If the video helped you, please like it and subscribe to my channel and share them as much as you can with your friends, and please return for more videos in chemistry. Bye-bye.